So in this example, we have a cube root situation. Even though we don't see a cube root, it's a cube root because we know now that if you see 1/3 right here, if I say, for example, x raised to 1/3, this is the same thing as saying the cube root of x. That's what this means. These things are equivalent. So now that we know, I know that there is a cube root here somewhere. So whatever is raised to 1/3 is going to go inside the cube root. Also, I know that if I have x raised to 1/3, and if I raise to 3, that turns into an x. Because I'm raising it by the index. This is the same thing as saying cube root of x raised to 3. This is how we cancel the exponent. This is how we cancel the radical. It's the same thing. To cancel the radical or the exponent, we raise it by the index. We raise it by the m right here. So this is extremely important to remember. Alright, let's do this. So I have 4 times 2x plus 6 raised to 1/3 minus 9 equals 3. Now I can only do this raising by index once I have the radical part by itself. Do I have the radical part by itself right now? No. I have a 4 being multiplied and 9 being subtracted. So I need to get rid of those two things first. Now, PEMDAS tells me that I need to do multiplication division first, but this is not PEMDAS. This is solving, so this is the opposite. So I'm going to do addition subtraction first. So I'm going to add 9 to both sides. Once I add 9 to both sides, the 9's cancel out. And I'm left with 4 times 2x plus 6 raised to 1/3 equals, oh, this 9 doesn't cancel out, my bad. This 9 actually becomes a. So I get 12 over here. Right. Now I need to get rid of the 4. The 4 is being multiplied, so I'm going to have to divide by 4 on both sides. So what do I get? I get 2x plus 6 raised to 1/3 equals 12 divided by 4, which is 3. Now I can see right here, x raised to 1/3 raised to 3 gives me x. That's how we cancel out the 3's. That's how we cancel out the exponent. So I need to do something like that. I need to do that magic right here to solve this, to get the x out of the radical. So how do I do that? I have 2x plus 6 raised to 1/3 equals 3. So how do I get rid of that 1/3? Well, here's what I'm going to do. I'm going to raise all of this to the 3rd power and do the same on the right side. And when I do that, this 3 crosses out this 3. So I don't have an exponent outside now. So what do I have? Well, I have 2x plus 6 equals 3 raised to 3, which is 27. Now I can solve for this x. To solve for the x, I need to subtract the 6. So I get 2x. The 6 cancels out. So I get 2x equals 21. And so x is equals to 21 over 2. Mr. Wilson, you there, Mr. Wilson? Sorry, never mind. So I feel that my answer is 21 over 2. Let's do a quick check. See if that actually is correct. All right. Always check your work. I'm going to do a quick check right here. My original equation was, oh, I didn't have this. So my original equation was 4 times 2x plus 6 raised to 1/3 minus 9 equals 3. I'm going to replace what I have. I have 2 times 21 over 2 plus 6 raised to 1/3 minus 9 equals 3. This 2 cancels out this 2. So I'm left with 4 times 21 plus 6 minus 9. This is raised to 1/3 minus 9 equals 3. So 4 times 27 raised to 1/3 minus 9 equals 3. 27 raised to 1/3 is the same thing as saying the cube root of 27 minus 9 equals 3. Well, what is cube root of 27? The cube root of 27 is 3. And I'm going to put a question mark here because we don't know if that's true or not. So what is 4 times 3? 4 times 3 is 12. So I get 12 minus 9 equals 3. 12 minus 9 is 3. 3 equals 3. That means I was correct. Let me give you a minute to take notes. It's okay if you take pictures, but you need to copy the notes in your notebook still. So let's make sure that you do that. All right? And I'm going to leave this here for a couple of minutes for you guys to take notes. You should not be happy just taking the pictures. Let's go.